Hi everyone, I am Priya. I am here to explain about house price prediction. These are my team members Apeksha Tonsal, Rakshita Dabadi, Rakshita Rudramani. Introduction of our project. Our project aims to predict house pricing using machine learning models based on various housing features like median income, number of rooms, population, and location. We use two different modules, linear regression and decision tree regression. Linear regression assumes a straight line relationship between features and house prices. Decision tree regression splits the data into smaller groups to capture the complex patterns. First block of code is importing the necessary libraries for performing regression analysis using machine learning. First step, loading the data. You are using the California housing dataset, which contains various features about houses in California. Example, average income, number of rooms, etc., and their corresponding prices. The dataset is either loaded from a built-in sources or from a custom CSV file, depending on the choice of use custom dataset. Pre-processing in the dataset. Features and target split. The dataset is split into two parts, X features, Y target. The input variables that will be used to predict the target. Y, the output variable which is price of the house. Next will be continued by my friend.
Hello everyone, I am Rakshita GR. I am here to explain about train test split. The data is divided into training set 80% and the testing set 20%. Using the train test split function, the model will learn from the training set and be evaluated on the testing set. Manual explanation of standardization, future scaling. Standardization ensures that all features have the same scale, preventing features with larger range like total rooms from dominating smaller ones like median income. Steps: compute mean and standard deviation. Find the average mean of each features. Find the standard deviation spread of each features. Transform each value. Subtract the mean from each value divided by the standard deviation. Formula: z is equal to x minus mean divided by standard deviation. Third step, apply the train and test data. Standardize training data. Use the same mean and standard deviation for the test data to make data models for the model like linear regression, which ensures the equal features. Thank you. Thank you. Next will be continued by Apeksha Tanshal.
Hello everyone, I'm Apeksha, making predictions and evaluating the models your part of our house price predictions project. Now let's talk about the model training. We have used two different algorithms for our house price prediction project: linear regression and decision tree regressor. First, linear regression. This model tries to draw a straight line that best fits the data. It learns the relationship between the input features like number of rooms or location and the house price by calculating coefficients. These coefficients tell us how much each feature contributes to the final prediction. Next, decision tree regressor. This model works a bit differently. It splits the dataset into a smaller segment based on feature values. For each segment, it looks at the average house price and uses that as a prediction. Decision trees are more flexible and are great at handling complex non-linear relationship between features. Um, Making predictions. Once the models were trained, we used them to make predictions on our test datasets. The predictions made by linear regression are stored in Y-pred and the predictions from the decision tree are stored in Y-pred tree. These predicted values present the model's estimate of the house prices based on the features in the test set. Next, evaluating the models to check how well our models are performing. We use two important evaluation metrics, that is MAE and MSE. MAE is nothing but mean absolute error. This tells us the average difference between the predicted and actual prices. It gives us a simple measure of accuracy. Next, mean squared error, that is MSE. This matrix is similar, but it squares the differences. That means it penalizes large errors more heavily. In both cases, however, lower values of MAE and MSE mean better performance. So, by comparing these values for both models, we can decide which one is predicting house prices more accurately. The next will be continued by Rakshita.
I'm Rakshita. The last part of our code it is an visualization. We can be created the scatter plots or it can be compare the actual house price in the y-axis and the predicted price in the both the models. Each model can be predicted or plotted in the separate series of finite points. The linear regression predictions in the y predict linear. The decision tree predictions. The closure points are with the diagonal lines. The better the model predictions can be matches the actual values. The scatter points that are be the further in the diagonal lines, it can be indicated the poor predictions. It is our output. The comparison of an predictions. The prediction price it is an lies on the y-axis. The actual price it is lies on the x-axis. The blue color indicates the linear regressions. Red color indicates the decision tree. Last part, conclusion. By the looking of an MAE, MSE are the visualizations, can you determine by the model of an perform better? The linear regressions are be typically performs well when there are be the linear relationships between the futures and the targets. While the decision tree can be handled by the more complex on the non-linear relationships but might be overfit by the data if they are be properly unused. Thank you.